These are the projectile motion concept answers. First, describe the shape of a projectile's path. Whether you kick it or hit it upward, or you just launch it horizontally, it's going to be parabolic. So this would be the second half of the parabola, like if I started from here over, or it would be the whole thing upside down if I launch it upward at an angle. But the path is going to be that of a parabola. How does the speed of a projectile when it's launched at an angle compare to its speed upon returning to its starting height? The speed is actually going to be the same. If the blue arrow is the total speed of the projectile, the red being the x part of the speed and the green being the y part of the speed, you can see that it does slow down on its way up because the y speed starts disappearing because of gravity, but it gets all of that on its way back down. So the blue arrows are actually the exact same size, just in a slightly different direction. So if it was launched with 30 meters per second of speed, it's going to land with 30 meters per second of speed. What is the acceleration of a projectile at the top of its path? Well, it's the same on its way up at the top of the path and when it's on its way back down. It is always negative 9.8 meters per second squared because the only force acting on a projectile while it's in midair is the force of gravity. Assume that we have two guns. One fires a bullet with 100 meters per second of speed. The other one fires it with 200 meters per second of speed, or just one fires twice as fast as the other. How do the horizontal distances that they travel compare to one another? Well, we know that the horizontal speed of a projectile has no effect on the vertical movement of that projectile. What that means is that if the gun is set up at a particular height h, which means it's going to take 1 second for the projectile to leave the gun and get to the ground, for both objects, they're both going to have that 1 second of flight time before they hit the ground. So if this one is moving 100 meters per second and it's got 1 second to move, it's going to travel 100 meters. If it's traveling twice as fast, 200 meters per second, it's going to go 200 meters. So if it's going twice as fast, it's going to go twice as far, because the vertical movement is not affected by the horizontal speed of a projectile at all. What happens to the speed of a projectile in the x and y directions during its flight when it's shot horizontally or at an angle? Well, we kind of touched on this in a previous question. The red arrow represents the speed in the x direction, and the green arrow represents the speed in the y direction. Well, the x direction speed stays the same all the time. That red arrow is always the same, whether it's launched at an angle or if it just starts here and is fired horizontally, because there's no force trying to slow down the football pushing back to the left. What about the green arrow? Well, you can see the green arrow gets smaller and smaller and smaller on its way up. That's because gravity is pulling it downward, slowing it down and stopping it from moving upward. Once it reaches the top of the path, or if it's launched horizontally and starts here, it's going to be moving downward faster and faster and faster because now gravity is accelerating it downward, just like it was over here at 9.8 meters per second squared, but it's giving it that speed back on its way down. So on the way up, the y speed gets smaller, smaller, smaller until it stops, and then it gets faster and faster and faster on the way down. What forces are acting on a projectile while it's in flight? It is just the force of gravity. There's nothing up in midair that's pushing the soccer ball forward or back, so it's only the force of gravity acting on a projectile, any projectile, while in midair. If we ignore air resistance, how would the distance of two marbles or any two objects firing out of a cannon, in this particular case, if one has a different mass than the other? In this case, the question asks for mass that's twice as much, but it could be any difference in mass. When they're shot with identical speeds, they're going to land at the exact same place. The reason for that, and we talked about this in kinematics, is that two objects, does not matter which one's heavier than the other, in this case it's a bowling ball and feathers, are going to fall with the exact same rate of 9.8 meters per second squared when we don't worry about air resistance. And we're not worried about air resistance in this problem. So the baseball here versus the bowling ball, they're going to land at the same rate because they're both falling downward at 9.8 meters per second squared. And since they're both going to be in the air for the same amount of time, if they're both fired horizontally with the same speed, they're going to land at the exact same spot. How does the speed of a projectile when launched at an angle compare to its speed at the top of the path? You can see the blue arrow here is the speed when you put the x and y together, and it's getting smaller. It's getting smaller on the way up until it's not even there anymore. That doesn't mean it doesn't have any speed. It just means all of the speed is the x speed. It's the red one here because all the y goes away. So the speed was largest down here at the bottom, and it's at its smallest here at the top when all the y goes away and the only thing that's left is the x speed. And those are all the answers to the concept questions for projectile motion. If you have any questions, email me or let me know, and hopefully that helps you out.